Hi, it's me, Dr. Prasad Puthiyillam. On my YouTube channel, My Intuition, offering free regular chemistry as well as entrance coaching classes on chemistry as well as learning mathematics. This is class number 3 of structure of atoms, atomic models, mainly J.J. Thomson's atomic model and Rutherford's nuclear model of atom, atomic number and mass number, isobars and isotopes. Thomson's model of atoms. J.J. Thomson in 1898 proposed that an atom possesses a spherical shape of a radius of approximately 10 to the power minus 10 meter. That means the spherical shape having positive charge on which the electrons are embedded or electrons are attached. Just like a watermelon with the red colored juicy portion as the positive charge, having the seeds as electron. Rutherford further modified the experiment. He used alpha particles, a box which produces the alpha particles with a lead screen with a slit and a gold foil. A gold foil is thin, a very thin gold foil is used, and fluorescent screens were used with a microscope. Okay, so this after when alpha particles are formed, it is allowed to pass through the slit, and when it hits the gold foil, a thin sheet of gold, he observed that most of the alpha particles are passing in a straight line and hitting the screen which is kept in front of that. Some of the alpha particles are deviating, and very less amount of alpha particles are deviating such that almost creates an angle of 180 degree. That means most of the alpha particles are going in a straight way. Very less alpha particles are deviated to certain angle, and few alpha particles are almost coming back, or it goes to a 180 degree deviation. So from these observations one can conclude, or he concluded, therefore concluded that the experiments were done by Rutherford, Hans Geiger and Ernest Marsden. Those two were Rutherford's students. The experiment they named as alpha particle scattering experiment, and they observed that the same thing, that most of the alpha particles are passing through the gold foil or through the atom of the gold, and they are undeflected. A small fraction of alpha particle was deflected by small angle, and a very few alpha particles, that is approximately 1 in 20,000, they bounce back, that were deflected nearly 180 degree. Okay, so Rutherford drew the following conclusion regarding the structure of atom as a spherical shape only, with a nucleus at the center having positive charge. Okay, so alpha particles, they are having the positive charge. When alpha particles are allowed to strike on the gold foil, most of the alpha particles pass through in a straight line. Okay, that was not deviated by anything. That means there's no such positive charge. Entire surface, the spherical shape is not having positive charge. If positive charge is there, alpha particle will be reflected, because opposite charged, like same charges, they will repel. Okay, so from this we can say that, or Rutherford concluded that most of the spaces in atom is empty, and few alpha particles got deviated. Okay, so that deviation is represented here, a small deviation, whereas a very little alpha particle, they got deflected to a 180. So it can be also represented that a positive charge center is there, a very small portion of the atom, a very small portion of the atom, or very small volume of the atom is having the positive charge, that is protons, as well as say no, we call it as nucleons. Okay, so this the radius of the atom, the entire atom, he concluded that it is approximately about 10 to the minus 10 meter, and radius of the central positive charge or the nucleus is 10 to the power minus 15 meter. Okay, so to get an idea about what is the size of the atom and the size of nucleus, we just given a comparison. Consider the nucleus as a cricket ball, then the atom, the circular part represents the playground. So if we consider it as a playground, then the radius of the playground will be approximately 5 kilometers. Okay, so we can imagine a cricket ball and a stadium or a ground of 5 kilometers. Then that is the we can imagine as the what is the size of the nucleus. So the positive charge center, it is very small, not as proposed by the J.J. Thomson in a say watermelon type structure. That is not there. That is experimentally proved by Rutherford's nuclear model. So he proposed a model to atoms. Rutherford's atom model It is represented in the picture. So Rutherford proposed the nuclear model of atom. According to his model, the positive charge and most of the mass of the atom was densely concentrated in extremely small region. This very small portion we called as nucleus. Okay, so the here P, the picture, the P represents the nucleus. Okay, P means a positive charged center. The nucleus is surrounded by electrons that moves around the nucleus with a very high speed in a circular path called orbit. Okay, so the movement of electron is a very fast movement of electrons. He said that that is the circular movement of electron in a path which we called as a orbit. It just in a circular path. It resembles our solar system. Okay, so we can say that the positive charge center or the nucleus, if we consider it as a sun, and the electrons as the different planets revolving around the sun. So this model gives the that represent that idea. And the electrons and the nucleus are held together by electrostatic force of attraction. Okay, so these are the conclusion by Rutherford, which was not existing now because the continuous movement of electron and speed wave movement of electrons will create the discharge of energy, and finally the atom will collapse. And as per this model, we can say that atom will not exist for more than 1 hour, or even less than that. The atoms should collapse. Okay, therefore, even Rutherford model also does not exist now. That is connected to the next classes. Why it is, that will be explained. Now, when atom is considered, it has got atomic number as well as mass number. The number of protons present in the nucleus is equal to the atomic number. So the what we call as the atomic number, that is the number of protons. So when number of protons are there, we know the atom is neutral charged. So the equal number of electrons also should be there. Therefore, number of protons is equal to the number of electrons. Therefore, atomic number Z can also be connected as the number of electrons. Therefore, Z is equal to number of protons in the nucleus of an atom, or it is equal to number of electrons in a neutral atom. The protons and neutrons, collectively we call them as nucleons. The positive charge on nucleus is mainly due to protons only, because neutrons are neutral charged. There is no positive charge, no negative charge. The total mass of the nucleus is due to the presence of protons and neutrons together. Okay, so we can say that the mass number A, that is the total sum total of protons and neutrons, or we can say number of protons Z plus number of neutrons N, that is the mass number. So this gives the definition of atomic number and mass number. Now, how we represent this mass number and atomic number in an atom? If you represent an atom with X, say if consider an atom as X, okay, the atomic mass number or the mass number A is represented as a superscript on the left hand side of that atom, or we write like this: A represents the mass number, and the atomic number Z, it is presented as subscript, okay, on the left hand side. Okay, so we can represent the atomic number like this. So mass number as well as atomic number of an atom can be represented like this. So isobars are the atoms with the same mass number but different atomic number. Say example, carbon having 14 mass number and 6 as the atomic number, whereas nitrogen also having the same mass number 14, but it is atomic number is 7. Okay, when atomic number is different means the number of electrons or number of proton is different. In carbon to nitrogen, therefore they are two different elements, and but it has got same mass number. So such type of elements we call them as isobars. They are isobars. Isotopes, it is just opposite to that of isobar, where there we had a same mass number. Here different mass number but same atomic number. An element with the same atomic number but different mass number. Say example, protium is isotope of hydrogen. Okay, so it has got a 1 proton or atomic number 1 and mass number 1. Deuterium, represented as D, it has got a mass number of 2, atomic number 1. Tritium, it is represented by T, it has got a mass number of 3 and atomic number 1. So all these are the isotopes of hydrogen, almost same property. That means that it depends upon the property of an element, it depends upon the number of electrons or number of protons. Okay, that both are same. Number of protons will be equal to number of electrons. So number of electron, how many number of electrons present, that determines the property of element. So here the number of electrons in protium, deuterium and tritium are same. Therefore isotopes are having almost same chemical property, whereas isobars are not. So represented with the carbon 14 and nitrogen 14. They are isobars. Their number of electrons are different. Therefore they are having different chemical properties. Another example for isotopes that of carbon, carbon 12, carbon 13, carbon 14. So we want say carbon 12, 6, carbon 13, 6, carbon 14, 6, because 6 atomic number is the same. So we just represent the isotope as carbon 12, carbon 13, carbon 14. Likewise, chlorine also has got isotopes, chlorine 35 and 17 is the atomic mass, atomic number. Chlorine 37 has atomic mass and mass number, and 17 is the atomic number. Therefore, chlorine 35 and chlorine 37, they are also example for isotopes. Okay, so thank you very much for watching my video. Please do subscribe my YouTube channel. More classes are uploading to my YouTube channel, My Intuition. Once again, thank you very much and have a nice day.